Alright, law 4 and 5. We've kind of looked at these already, but we'll have a bit of practice here. Basically, anything that's in brackets, and if we have a power outside those brackets, the power affects both terms. So in this case, in the proofs at the top, it becomes a to the power n and b to the power n. So if we were working with actual numbers, we could do a squared times 2 and b 3 times b to the power 3 times 2, giving us a to the power 4 and b 6. Because the 2 here is out the front, we're not using that, but it will impact the 2 in the brackets. So let's leave the 2 out the front for the moment, and this is going to become 2 to the power 1 times 3, which is 3, and c to the power 1 times 3, which is 3, and d to the power 21, closing brackets. Now, this is really saying 2 times everything in the brackets, and we can just really add that as another power. So we could write this as 2 to the power 4, c to the power 3, and d to the power 21. So we've incorporated the 2 that was outside the brackets in our final answer. Same thing with division. Anything that's outside the brackets will impact everything that's inside the brackets. So you can see here, this is going to become a 2 times 5, which is 10, b 1 times 5, which is b 5, and d 1 times 5, which is d 5. We have no common bases there, so we can't simplify that anymore. So let's leave it as that. Alright, a little tricky this one again. So I'm just going to write it out as, because we've got -6, this can be a little confusing. So -6, we're really squaring that whole value. And then a to the power 6 over c to the power 2. 1 times 2 being 2, and 3 times 2 being 6. The reason I've done that is -6 times -6, which is the same as -6 squared, is positive 36, and then a6 over c squared. So just be careful with your negatives. If you're squaring it or cubing something, it will become a positive value. We'll see a couple more of those down here. So we're not going to do anything with this stuff out the front for the moment. And in the brackets, where -2 times -2 is 4, and then a to the power 6 and b to the power 4, and using our law 1 with multiplication, meaning we're adding the powers. Well, in this case, -4 times +4 is -16. 2 plus 6 is 8, and 3 plus 4 is 7. So that's our final answer there. -5 staying out the front of this one. Well, this is getting confusing. 3 to the power 10, 3 to the power. So multiplying those powers, 5 times 2 is 10, m 6, and n 4. All over, I'm going to leave this in brackets for the moment, -3 to the power 6, m to the power 6, oh sorry, that should be a 9, and n to the power 3. So let's go through from here. So using law 2, we can do a bit of cancelling. This is a bit confusing with that negative, but 3 to the power 9 cancels with 3 to the power 10, leaving us with 1 and 3 to the power 1. The m6 cancel together, and the n3, n to the power 3, leaves us with n to the power 1 on top there. Oh, where's my time come up? There we go. Again, fairly difficult question. You won't come across many of these. So we're left with negative 5 times 3 n over negative 1, which gets us to negative 15n over negative 1. And we can cancel these negatives, leaving us with just 15n. Again, that's a fairly difficult question. You won't really get many of those, but if you just follow these rules through, and there are different ways to approach these problems, I'm sure you'll be fine.